Guys, today we're going to be solving LeetCode question 418 sentence screen fitting. This is a medium level problem. This is an appropriately designated medium level problem. It has actually many ways of solving it. It has a dynamic programming solution. It has, if you just follow a natural line of thinking, you will come up with a for loop approach. And if you just follow that, that is also a good solution. The solution that I'm going to present is a little shorter and it's elegant because it's short and concise. It's fast. It's also one of the trickier ones to understand, which is why I thought it's a good solution to pick up for this video. Now, I hope you've read the problem. It's well worded, it's easy to pick up. But basically, what they've told us is they will give us an array of strings, an array of words, and then we have to tell them how many times we can fit the sentence formed by these words onto a screen, which is constrained by some columns and rows. Pretty straightforward. So, since they want us to tell them how many times the entire sentence can be fitted onto this screen, the first thing we'll do is for the solution is concatenate all the words in this array, okay, and form that string. That's the sentence string. And for the sake of explanation, I won't use hello world. Let me use hello my amazing world, just so I can cover more edge cases as I'm explaining. Also, let's replace that. Let's represent the spaces within the string by underscores so that we can distinguish between the spaces on the text editor and the sentence. Now, if you think of, we'll also append a space at the end of this so that there's a space which can precede the next sentence that follows. Now we have to tell them how many times the same sentence can be fit onto the screen. Basically what they're telling us is, suppose we had an infinite string like this, right? How many times can we fit this infinite string onto our screen before we run out of space on our screen? Basically, what they're telling us is, we have given you this infinite string. Now, we have to pick up these words in segments of 8. Okay, let's assume we have 8 columns on our screen and rows, let's just say 12. Okay, what they're saying is, if we pick up words in batches of 8 characters and fit in as many words as possible into that segment or bucket and then move on to the next row, how many times can we keep doing this? Like, okay, how many times after doing this for all the rows, after I'm so sorry, they're asking us, after doing this for all the rows where we fit in as many words as possible into buckets of 8 characters, because we have only 8 columns, when we run out of rows, how many times have we fitted this sentence onto the screen is what we have to tell them. Cool. So the way we'll go about this is in a greedy manner. Okay, we'll, our segment or bucket, however you want to think about it, we'll try to fit in as many words as possible. So first we'll try to fit in 8 characters, okay, which ends at this space. So basically we'll pick up both hello and my. It's not like we'll pick up hello for this row and then put my in the next row. We'll go greedily about it. We want to pack in as many the same sentence on the screen as many times as possible. Okay, so okay, so the key to this solution is one variable called cursor. Okay, um, now this cursor will be initialized as 0, which basically means it will start here. Where you see this blinking cursor, that's exactly where we'll start. So we need to get into this mindset of this cursor. Okay, this is the key to our solution. Now this cursor will, so we'll, what we'll try to do is natural way of thinking. We'll try and fill in as many words as possible onto one row of the screen. Okay, the row, first row, then we'll move on to the second row, then we'll move on to the third row, and like this we'll go on to the eighth row. So if you think about it, we will have a main outer loop of main, outer, for loop or while loop, whichever one you prefer, which will go through all these rows. Now, this cursor, our aim with this cursor is that at the end of every iteration of this for loop, this cursor should point to the next character that will be put on the next row. Okay, keep this in mind always. Um, and which basically means that whichever words have come before this cursor, okay, and this cursor will move along this infinite string, okay, don't confuse this with the fact that okay, this cursor is a cursor on the screen. No, this cursor is a cursor which will move along this infinite string. And if you're thinking how will we have an infinite string, no, we won't have an infinite string, we won't construct an infinite string, we will use the mod operator to simulate that infinite string. That is more of, you know, mathematical logic. You'll understand that while we code. But this cursor will move along this infinite string, not on the screen. Okay, don't confuse it with that. So basically, the main idea about this cursor is whatever this cursor will, at the end of every row's iteration, this cursor will point to the next character that will be put on to the next row, to the for the that will be put on to the row that will come in the next iteration of this main for loop. And whatever is before this cursor has already been fit onto the screen. Now if you think about it, if this cursor signifies whatever we have already fit onto the screen, it is actually the key to our answer, right? That is what they want. They want us to tell them how many times we have fitted this sentence onto the screen, so this cursor will actually drive us to the solution. Okay, now we will dive right into coding. You might feel that I'm diving in too soon, but honestly there's no more background to give apart from this for the solution. So let's, like the rest of the solution, I'll explain as we code. Let me comment this out. I'm just keeping it around so that I can refer to it if I want to explain more. Cool, let's start. I'll form the sentence first by concatenating all the words in this sentence array. And I'm using Swift for coding. I know it's not a very common language, you might not be familiar with it, but it's very readable. And I'll explain every line of code, so you should be able to follow easily. I've made a typo there. And I'm going to use verbose variable names just so that it's easier for you to follow. I'm in no way encouraging long variable names. Cool. So I'll form the I'll concatenate the words separated by spaces, and I'll append a space at the end, this one, right? And I'll also convert it to a character array. Cool, so that it's easy to deal with. Cool, and let's initialize our cursor at 0, which makes sense, right? Initializing it at 0, because at 0, if it's at 0, it means no characters have been included yet, and it's pointing to the first character that's going to be inserted into the first row, which is H in our case. Cool, let's also save a variable. Let's also have a constant for the character array length, because we'll use this for a bit. Cool, now we are ready to start the for loop. So as I mentioned before, we'll go through every row of the screen and try to fit in as many words as possible onto one row and then move on to the next row. So for I in 0 to rows -1. Cool. Now we'll try and fit in as many words as possible into these rows. How do we simulate that? How do we represent that? Basically, we'll try and move our cursor to the maximum distance we can for this row, right? And how do we do that? By oh god, I'm sorry for these typos. By moving the cursor by all the columns, by maximum columns. Now we'll see where we landed, and then we'll go about correcting. Okay. So as I mentioned before, we our cursor by the end of this iteration should always point to the next character which will be inserted into the next row, right? So now when we do this, okay, we we add all the columns to the cursor. There are only two possibilities. There are only two types of characters that we can land on. Okay, we can either land on a space, okay, which is ideal because then we know that hey, everything before this space has been included. We were able to we took the maximum jump possible, we landed on a space. We can be sure that whatever came before this space has now been included onto our screen. Okay, what is the other case? The other case is that we land in the middle of a word, we land on a letter. Okay, now for sure, like we can be sure at this point that okay, if you're in the middle of the word, anything after this, any part of this word that comes after this cursor or any of the words after cannot be fit onto this row. Maybe we can try for this in the next row, but we can be sure that any word that came before this partially filled word can be fit onto the row, right? If you like think about it. So what we'll do is we'll trace back on this word which we have landed on and try to find the nearest space, because we know that anything before this space has been able to be accommodated on this current row, and then we'll try and fit this word that we have landed on in the next row. So basically we have to get to the starting of this word on which we have landed, because our cursor should always point to the first letter of the word that has to be inserted into the next row. So basically, we have to find that space again. If we land in the middle of the row, we have to find the space right before this word. Okay. Now, basically, we just have an if and else inside this for loop where we have one if to see whether we landed on a space, and if we did not, we the code to find that space. Okay. Cool. So if joint sentence, this is the character array. Let me type this out so that it's easier to refer to. Okay, this is the array. Okay, this is imagine this in a character array. This is what joint sentence represents. Okay, now this is where we'll simulate that infinite string. Okay, we'll use the mod operator. Okay, okay, now by modding it by the entire by this length, we are basically simulating the infinite string, right? Like we fill this once, we fill this once, we fill this once, we fill this once, and whatever remainder we have would signify where we land. Like if you do this math on your notebook on the side, this should be easy to grasp. Okay, but this is basically where how we are simulating that infinite string that I am typed here. Cool. So as I said, first let's check if we landed on a space. If we did, we will increment our cursor by 1. Okay. Now this is a detail that is easy to miss, easy to overlook, but it gets tricky when you think about it, when you actually think about this increment. Why did we do this plus? It was basically to move on to the next letter, right? We do 1 plus because we were here before this space, right? When cursor is 0, it means we are before this age. When cursor is at whatever number, whatever index this is at, it means we are here. So we need to increment it and get to the next letter, okay, before the next letter, which means we need to get here, which is why we do this plus 1. Now one thing to keep in mind always is that this cursor does not represent our position on the screen itself. Okay, this space could be represented on the screen by three spaces, four spaces, no space at all. Maybe it represents one space, because you think about it, like it is possible that we had 11 columns and our cursor was here, and then when the next, okay, let me just keep using my example. Okay, suppose we had 8 columns and we ended here, because we can't fit more words on this row. Our next row will start with amazing. So if you think about it, there's actually no space after this y or before this a. So don't try and equate this plus with what you see on the screen. Okay, it is also possible that maybe we had 10 columns. Okay, and there were two more spaces after this. So these two spaces are nowhere equal to this plus one. Okay, this plus one is only to move our cursor along this and to get to the next letter that we're going to insert into the next row. Okay, this cursor only moves along this infinite string, and all our math, even for the final solution, is based around this sentence. Okay, it is nowhere based on what we have on our positions on the screen. Like, it is dictated by how much space we have per row on the screen, but the entire math of it all is based on this string. Okay, cool. Now the else is basically where we land in this else when we basically land in the middle of a word. Okay, and when that happens, we have to trace back and find the space before this word. Okay, so that's what we'll do. So just some safety checks. We don't want to increment below 0 while cursor is greater than 0, and okay, just going to copy paste this. I hope that does not confuse you. But so while cursor -1 is not equal to space, this while loop basically means that keep going back until we find the space before this word. Okay, now, so as I said, this cursor at all points will represent the position of this cursor on the infinite string. By this infinite string, understand that this is not an actual infinite string that we have used or constructed, like just something we have simulated and the mentality that we have held while coding. This cursor will always represent how many words we have already fitted onto the screen, right? So our actual solution is very straightforward. It's cursor upon this joint sentence length, which makes sense, right? Like, joint sentence length is the full length of this, and this cursor is representing where we are along this, right? So if we are in the middle of here, hello my, so like this division will get us this, like how many times this sentence was included. Like, it should be straightforward math from this point on, and that's about it. Before running, let me just check. Okay, let's comment this out. Okay, we can't use single quotes in here. Let's use, okay, sorry guys, I actually made quite some errors while typing. Let's see if this works. Okay, cool. It's actually not quite fast. I think my earlier submissions were fast. I don't know how that works. Anyway, the time complexity of the solution would be order of the rows into the length of longest word, which makes sense, right? Like we might like this while this multiplication, the length of longest word is for this while loop, because what if we end up on a really on a really large word at the end of a very large word, and we have to trace all the way back to find the space before it. So the worst case complexity would be order of rows into the length of the longest word, right? Cool, guys, that is it. I hope I did a decent job of explaining the solution. Happy lead coding. Have a good day or night wherever you are. See you guys in the next video. Bye. Before running, let me just check. Okay, let's comment this out. Okay, okay, we can't use single quotes in here. Let's use. Okay, sorry guys, I actually made quite some errors while typing. Let's see if this works. Okay. Cool. It's actually not quite fast. I think my earlier submissions were fast. I don't know how that works. Anyway, the time complexity of the solution would be order of the rows into the length of longest word, which makes sense, right? Like we might like this while this multiplication, the length of longest word is for this while loop, because what if we end up on a really on a really large word at the end of a very large word, and we have to trace all the way back to find the space before it. So the worst case complexity would be order of rows into the length of the longest word, right? Cool, guys, that is it. I hope I did a decent job of explaining the solution. Happy lead coding. Have a good day or night wherever you are. See you guys in the next video. Bye.